So in today's lesson, we're going to solve quadratics using the quadratic formula, which is something you guys learned in Algebra 1. So hopefully it's not going to be an overwhelming task today. So when you solve using completing the square on the general formula ax squared plus bx plus c, you get the formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You pull the a from the coefficient of x squared, you pull the b from the coefficient of x to the first, and you pull the c from the constant. Then you plug those into the quadratic formula. And you can solve any quadratic equation even if you cannot factor it with this formula. So that's what we're going to do first. And we're going to talk about what we do with this. The discriminant's what's under the radical. That's the b squared minus 4ac, and the discriminant tells the number and types of answers that you'll get. The discriminant can be positive, negative, or zero, and since the discriminant is under a radical, think about what it means if you have a positive or negative number or zero under the radical, right? Okay, so here, when it talks about the value of the discriminant, we're going to actually talk about what do these look like. So if it's negative, then what we're talking about is what's under the radical is negative, right? So we would have a negative number under there, right? If we got a zero, that means there would end up being a zero underneath that radical. Two real rational solutions means that you're going to just get a perfect square here. So you're going to get something squared underneath there, okay? And then the last one is going to be something that is not a perfect square. So it's going to be a number that we cannot take the square root of and get a whole number, okay? So the options here are imaginary. That's when we get something negative underneath the radical or as the discriminant. One real solution, that's when we get zero underneath there. And two real is when we get a perfect square under there. And then when it's not a perfect square, then we're going to get two real irrational solutions. So now we're going to work a problem. So we're going to find the value of the discriminant, and then we're going to describe what the roots are, whether they're real, imaginary, rational, or irrational, each of the quadratic equations. Then we're going to solve the equation using the quadratic formula. So the first thing we got to do is pull a, b, and c. So a is attached to the x squared, so that's going to be 2. B is attached to the x, so that's going to be 7. And then our constant is always going to be c. So now we're going to actually do the b squared minus 4ac. That's the discriminant. So that's what we're going to do first. So that means we're going to take the 7, square it, then we're going to subtract from it 4 times a, which was 2, and c, which was negative 11. So now we're just going to simplify this. This is going to be 49 minus 80, oh no, plus, because negative 4 times negative 11 is a positive 88. So what you should see is that we get 137 here. Now that is a positive number, but if I take the square root of 137, it's not a perfect square. 137 is not a perfect square. So we have two solutions here, right? And they are real solutions, because it's not a negative number under there, and they are irrational. And they are irrational, again, because I can't take it's not a perfect square, basically. That's what determines that it's irrational, okay? Now we're going to plug a, b, and c into the quadratic formula and solve for the variable, okay? So we've already got what's underneath that radical. That was 137. So all we're going to have to do when we plug this in is put that in underneath the radical. So again, our negative b is going to be minus 7. Plus or minus, we have the square root of 137. And then 2 times a was 2, so we're doing 2 times 2. Then we're just simplifying. That's all we're doing. So that's going to be negative 7 plus or minus the square root of 137 over 4. And that one can't be simplified any more than that. Just kind of watch for that b and anything that's out in front of that radical to see if you can simplify. So now let's go on to the next one. So this again, I said put the values in the variables in the formula, then write the formula. Order matters. Do what's under the radical first. That's our discriminant, which you're going to do b squared minus, then put the minus and then multiply 4 times a times c. then multiply 2 times a, then the next step is subtract. You know what I'm saying? Do the discriminant first. That's really the key here, okay? All right, so now the first thing we have to do with this problem is put it in descending order. So we have to go x squared. We're going to have to move that 4x to the other side. So we're going to subtract it. And then we're going to do plus 5. And we're going to always set these equal to 0, guys. That's what's going to give us the correct a, b, and c, okay? So a here is 1, because there's a 1 in front of the x squared. B is what's in front of the coefficient that is in front of the x to the first. And c is our constant. Going to do the discriminant again, so that's b squared minus 4ac. So we're going to then populate that. So that's going to be negative 4 squared minus 4 times a, which is 1, times c, which is 5. Now you should see that this is 16 minus 20, right? 4 times 1 times 5 is 20. So that's going to give us a negative 4. Now we talked before, if we get a negative answer for the discriminant, then it's going to be 2 solutions. And they're going to be complex, right? These 2 solutions are going to be complex, okay? Which means they're going to be imaginary, all right? So now we're going to plug these values into our quadratic formula. So that's going to be minus a minus 4 plus or minus the square root of negative 4 over 2 times 1. So let's go ahead and simplify this. Minus a minus is a 4, right? Now, you should know that when we do this, I'm just going to go plus or minus, and I'm going to do the square root of negative 1 times the square root of 4, because that's the way we've been doing this, just so you guys see that we can simplify that. So that's going to give us 4 plus or minus 2i over 2. Now, what you should be able to see is that we can simplify that even more, because 4 can be divided by 2. That's 2. So we're going to get 2 for this first term. And then 2 can be divided by 2. So it's going to be 2 plus or minus I as our 2 imaginary or complex solutions, however you want to say that. Again, we got to move this 63 to the other side. Then we're going to say what our A is, our B is, and our C. Put this in the discriminant, so we're going to do 2 squared minus 4 times A times C. And I can already tell that a negative times a negative is a positive, so this is going to end up giving me a positive number underneath the radical. So this is going to be 4 plus 252, which is equal to 256. So we can already say we're going to get 2 solutions, right? And they're going to be real solutions. Now let's see if they're going to be rational or irrational. So if we take the square root of this, then that gives us 16. So these are actually going to be rational solutions, which means it's a whole number, not something underneath the radical. So now we're going to, again, populate our quadratic formula. So we're going to do negative b, which would be negative 2 plus or minus. We've got the square root of 16, so we already got the 16. So I'm going to go ahead and put it right there. And then we're going to do 2 times 1, okay? So this is going to be negative 2 plus 16 over 2. That's 14 over 2, which is 7. Negative 2 minus 16 over 2. So that's going to be negative 18 over 2, which is negative 9. All right, so this next one, I'd like you guys to go ahead and try to do these 4. Come back to me after each one and check your answers. Again, going to pull our coefficients. 1, 8, negative 84. Going to do b squared, which is 8 squared minus 4 times a times c. That's going to give me 64 plus 336, which equals 400. If I take the square root of 400, that's 20, right? So this is going to be two real solutions, right? That are, again, rational. Two real rational solutions, okay? So here we go again, negative b, negative 8 plus or minus 20 over 2 times 1. So that's going to be negative 8 plus 20 divided by 2. That's 12 divided by 2, which is 6. Negative 8 minus 20 divided by 2. That's negative 28 divided by 2, which is negative 14. So there's your two solutions. Go ahead and do the next one and come back to me when you're done. B squared minus 4 times A times C, 25 minus 72. So this is equal to a negative 47. So this is going to give me two complex solutions, right? So we're going to go minus 5 plus or minus the square root of negative 47, 2 times A. So that's negative 5 plus or minus, I'm going to do the square root of negative 1 times the square root of 47, just to remind y'all. And this is 6. So then this is equal to negative 5 plus or minus I square root of 47 divided by 6. There's our two solutions. Do this next one, and then again come back to me. Seven b squared minus 4 times A times C. So that's 49 minus 52. That's a negative 3. So again, we're going to get two complex solutions, or imaginary. So I get negative b, which is negative 7, plus or minus the square root of negative 3 over 2 times 1. That's going to be negative 7 plus or minus. You should know that this is going to be I square root of 3 by now over 2. One more of these. Go ahead and do this one. Pause. Come back to me. B squared minus 4 times A times C. So this is going to be 25 plus 96. That's going to be equal to 121. 121, if I take square root of it, isn't that 11, y'all? So this is going to be two real rational solutions, right? Rational means that it's a perfect square under there, okay? All right, so again, negative b, negative and negative 5, plus or minus. Again, most common errors right there, y'all, making sure that you change the sign of that negative 5. 11 over 2 times 1. So this is going to be 5 plus or minus 11 over 2, right? So we're going to do 5 plus 11 over 2. That's 16 over 2, which is 8. 5 minus 11 over 2. That's going to be negative 6 over 2, which is negative 3. So hopefully these are working out for y'all. All right, so the last concept that we want to go over, if I can get this thing to go to the next screen, is the sum or difference of two cubes. Now, if you guys recall, when we did these, the way we did this is we could take the cube root of this, and the cube root is this, both of them actually, or we can take it to the 1/3 power. Either way, what we're going to get when we take cube root of x cubed was x. When we take the cube root of 64, we get 4, and whatever the sign was in the middle there, we're going to keep that. Now the second set of parentheses, we're going to square what's right here. That would be x squared. We're going to multiply the two terms together. That would be 4x. And we're going to put a plus sign here because there was a minus sign in the first set of parentheses. Then we're going to square the last term. Okay, so when we do this, we can obviously set this factor, which is right here, equal to 0 and solve that. That would be x equals 4. I'm going to tell you guys right now, anytime you have the sum or difference of two cubes, you're going to have one real solution and two complex solutions, okay? Always. So again, when I plug this in, and I could have seen that immediately because my a is 1, a equals 1, b equals 4, c equals 16. When I look at my discriminant, I'm going to do 4 squared minus 4 times a times c, right? So that's going to be 16 minus 64. And that's going to be negative, right? So that we know already that that's going to be two complex solutions, okay? All right, so let's work one of these. So here again, we're going to take the cube root of this, and I'm just going to take this to the 1/3 power. That's what I would do with the 64 too if I didn't know that it was 4, but I kind of know it's 4. So we got 4n minus 5, right? Okay, remember again, what we're doing for this next set of parentheses is we're squaring the first term. 4 squared is 16, n squared is n squared. For the middle term, we're going to multiply the two together, change the sign. That's going to be 20n, and then we're going to square that second term, which is going to be 25. So here we go again. We're going to set the 4n minus 5 equal to 0. We're going to add 5 to both sides. So 4n equals 5. And then we're going to divide both sides by 4. So one of our solutions is n is equal to 5 over 4. That's our real solution, okay? We're also going to have two complex solutions, right? So here we go again. A equals 16, b equals 20, c equals 25. We're going to find what's under that discriminant again. So we're going to do 20 squared minus 4 times a times c, right? I can already tell that that's going to be a negative answer there. Hopefully you can too. So we're going to get 400 minus 1600, which is equal to minus 1200, right? All right, so we're going to go negative b plus or minus, and we're going to take the square root of negative 1200 and divide that by 2 times 16. So that's going to give us negative 20. Okay, now I'm going to factor out this 1200. Plus or minus the square root of negative 1, square root of 400 times the square root of 3, right? All over 32. So now let's go ahead and simplify this. So we get negative 20 plus or minus, that's going to be 20i square root of 3 over 32. So we have to ask ourselves, what's the GCF of 20 and 32? That would be 4, so I'm going to divide 4 into both. So that would give me negative 5 plus or minus 5i square root of 3. And then 4 goes into 32 8 times. So there's our other two solutions. So we get one real, two imaginary. All right, let's see if you guys can do this last one, and then come back to me and check it when you're done. Again, going to take the cube root here. Remember, I can take the number to the 1/3 power either way, okay? So this is going to be 2x plus 7. Once again, I'm going to square that 2x. That's going to be 4x squared. Going to multiply the 2x times the 7. That's going to be 14x. And remember, if the sign in the first set of parentheses was positive, this sign's going to be negative. And then we're going to do 7 squared, which is 49. So we're going to set this 2x plus 7 equal to 0. Subtract the 7 from both sides. We get 2x equals negative 7. Divide both by 2. So x is equal to negative 7 over 2, or negative 3.5. Over here again, we're going to do our a equals 4, b equals negative 14, c equals 49. Going to do b squared negative 14 squared minus 4 times a times c. I can already tell that this is going to be an imaginary solution. So this is going to be 196 minus 784, which is equal to 588, negative 588, okay? Sorry, that doesn't look very clear. Let me fix that. Whoops. Dropped it. 784, so this is equal to negative 588. So we know it's going to be imaginary or complex because it's negative. So we're going to go minus a minus 14 plus or minus the square root of negative 588 divided by 2 times 4. All right, so that's going to give me 14 plus or minus, and I'm going to go ahead and factor this, negative 1, and it had 196 times 3. And 196 is a perfect square, y'all. And then we're going to divide that by 8. So this is going to be 14 plus or minus, that's going to be 14i, square root of 3, divided by 8. So the GCF of 14 and 8 is 2. So this is going to end up being 7 plus or minus 7i, square root of 3 over 4. So there's one of our solutions, or two of our solutions, and there's the other one.